Today we're going to start our unit on trigonometry, and we're going to start with a little bit of a review from Math 2 about trigonometry. The first thing we're going to review is right triangle reminders. First and foremost, remember that lowercase letters represent side lengths. And if you have two side lengths, we can use the Pythagorean theorem to find the third side length. Also, capital letters are used to represent angles. And we can also use our right triangle trigonometry, aka sine, cosine, and tangent, to create ratios to solve for angles or side lengths. I'd also like to point out that the capital angle is located opposite or across from its lowercase side length. Okay, just as a reminder, if we're talking about an angle using the notation theta, this side little a is opposite. Excuse me, I'm so sorry. If theta is here, b is opposite. Because it is across the triangle. Little a would be adjacent because it's next to the triangle, or excuse me, it's the side length next to the theta. And then of course c is always going to be my hypotenuse because it is across from the right angle and it is the longest side. So first we're going to remind ourselves about sine, cosine, and tangent. And I'm also going to use this time to introduce the three other trig ratios. Yes, there are a total of 6 trigonometric ratios. So the first one we know, sine, is the ratio of the opposite side over the hypotenuse. So for sine theta, my theta is in this corner, I would use the opposite side, which is b, over the hypotenuse, which is c. Sine theta equals b over c. The other ratio is called cosecant. Cosecant is the reciprocal function. A reciprocal function just means to flip it. So secant is the ratio of hypotenuse over opposite. So the secant is the reciprocal of sine, or the flip of sine. Secant is shortened by the letters CSC. So CSC stands for cosecant. Cosecant theta equals the hypotenuse, this time, over the opposite side. Next is cosine. Again, cosine is the adjacent side over the hypotenuse. So my theta is still down here in the corner. Cosine, of course, is abbreviated COS. So cosine theta equals adjacent over hypotenuse. So the adjacent side over the hypotenuse. Cosine's reciprocal function is called secant. Secant is abbreviated SEC. Secant is the hypotenuse divided by the adjacent side. It is the reciprocal, or the flip, of cosine. So secant theta equals little c over little a. Hypotenuse over adjacent. Last but not least, we have tangent. The ratio for tangent is the opposite side over the adjacent side. So tangent, TAN, tangent theta equals the opposite over the adjacent side. Tangent's reciprocal function is called cotangent. Cotangent is abbreviated COT. So cotangent of theta would be the adjacent over opposite side length. Cotangent is the reciprocal of tangent. All 6 of these words are vocabulary words, and I would strongly recommend you do vocab cards for all 6 trigonometric functions. Now we're going to put all 6 of them together with a practice problem that you see here. Find all 6 trigonometric ratios. So of course we're going to start with our 3 basic: sine theta, cosine theta, and tangent theta. My theta is up here in corner A. So sine represents the opposite over hypotenuse. So the opposite of A is side length 5, and the hypotenuse is 13. So sine theta equals 5 over 13. Cosine would be the adjacent over hypotenuse. So cosine is 12 over 13. 12 is the adjacent side. 13 is still the hypotenuse. And then tangent is opposite over adjacent. So 5 over 12. Now those are the first 3. We still have the 3 other trig functions. And remember, these are called the reciprocal functions. The reciprocal of sine theta is called cosecant, and it was CSC, cosecant theta, and it is the reciprocal of sine. So the reciprocal of sine would be the hypotenuse, which is 13, over opposite, which is 5. For cosine theta, its reciprocal is called secant, S-E-C. So secant theta, the reciprocal of cosine would be hypotenuse over adjacent. Then the reciprocal of tangent is called cotangent, and the reciprocal would be adjacent over opposite. These reciprocal functions are taking their partner, so to speak, and flipping the fraction. So sine theta was 5 over 13, which means cosecant theta is 13 over 5. We're just flipping the fraction. You may be asked to find the values of the 6 trigonometric functions of an angle in standard position. Standard position means I start at the vertex. One of my vertices is going to be at the origin, 0, 0. And then I'm going to move out to whatever point they indicate. So for this particular question, I want to go to the point 3, negative 4. So I'm going to start with one vertex at the origin, and my other vertex is going to be at the point 3, -4. Now, if I want to find 6 trigonometric functions, that means I need a right triangle. So I'm going to connect these points and create a right triangle with one vertex at the origin 0, 0, and the other vertex at the point 3, -4. There is my right triangle in standard position. Now all I have to do is label the values. I know that my horizontal leg is 3 units. The vertical leg is -4 units because I'm going down 4 units, so I do want to apply a negative there. The only thing left to do is to find the hypotenuse, that third side. Well, if I have 2 sides of a right triangle, I know how to find the third. I use Pythagorean theorem. A squared plus b squared equals c squared. My a value is 3. My b value is -4. And the c value is what we're trying to identify. So 9 plus 16 is, of course, 25. But I don't want c squared, I want c all by itself. So it is 5. So my hypotenuse is 5 units. We are going to take the positive value whenever dealing with the hypotenuse. So just keep it as +5. Now that we've properly labeled our triangle, I can find my 6 trigonometric functions. The only thing I am missing is where to put theta. Now, because this is in standard position, that means my vertex started at the origin. So theta is going to be in the corner by the origin. Please make sure you write that down. Theta is in the corner inside the triangle closest to the origin. It's very important to identify where we put theta because everything else falls from it. Sine theta, cosine theta, tangent theta. Those are the 3 that we know, and then we must identify the 3 that we just learned today. Cosecant theta is the reciprocal of sine. Secant theta is the reciprocal of cosine. And cotangent theta is the reciprocal of tangent. So starting at sine theta, sine is opposite over hypotenuse. Opposite of theta would be -4, and the hypotenuse is 5. Therefore, the cosecant theta would be 5 over -4. It does not matter whether your negative is in the numerator, denominator, or outside the fraction. Math Excel might be a little picky about where you put your negatives, so I would encourage you to always put your negatives in the numerator. Next is cosine theta. Cosine, of course, is adjacent over hypotenuse. So cosine theta equals 3 over 5. And the reciprocal secant theta would be 5 over 3. Last but not least is tangent theta. Tangent is opposite over adjacent. So opposite is -4, and adjacent would be 3. The reciprocal of that, or cotangent theta, would be 3 over -4. But as I mentioned previously, Math Excel would probably want you to put your negative in the numerator. It does not change the fact that the entire fraction is negative. Please make sure you complete the Math Excel called Trigonometry Ratio Practice.